So, in your Chapter 1 packet, homework 13 should be the last one there, and this is going to have a lot of stuff with absolute value. So just to refresh your memory, if I have the absolute value of 3, it's saying, well, how many places is 3 from 0 on the number line? And we know that it's 3 places. If I have the absolute value of -3, again, it's saying, well, how many places is -3 from 0 on the number line? And we still know that it's 3 places. So when they say the absolute value of what number equals 3, I'm actually going to have 2 answers because both a +3 and a -3 are 3 places from 0 on the number line. If you would have the absolute value of what number equals -3, on these ones here, we know absolute values are distances and never can equal negative numbers, so it would be a no solution answer. So what they're going to have you do on these first ones is, first of all, get the absolute value by itself, whether you add, subtract, multiply, or divide. Then they're going to have you list the possible answers. So on this first one, if I have -4 times the absolute value of x equals -32, I'm going to divide by my -4, and I'm going to have the absolute value of x equals 8. So what it's saying is, what numbers are 8 places from 0 on the number line? Well, you have 2 different values that are 8 places from 0 on the number line, so you're going to have 2 answers. Both 8 and -8 are 8 places from 0 on the number line. And most of the time when you do absolute values, you're either going to have 2 solutions or no solutions. The only time you get 1 solution is if you have a 0, because you can't have a positive and a -0. So on number 2, if we want to find the solutions of the absolute value of x minus 20 equals -13, to get the absolute value by itself, we're going to do what? Add our 20. So we're going to move our 20 over. We're going to add 20. So the absolute value of x would equal, and -13 plus 20 would give me 7. And so what it's asking is, what numbers are 7 places from 0 on the number line? So your answers would be 7 and -7. On the third one, if I have -5 times the absolute value of x equals 30, in order to solve that for x, we would divide by that -5. So we'd have the absolute value of x equals -6. What numbers are -6 places from 0? Well, since it's a distance, we're going to say nope. Because what's the absolute value of 6? It's a +6, right? What's the absolute value of -6? It's a +6, right? So when we do absolute values, can an absolute value equal a negative number? It never can, right? So our answer is going to be no solution. We can't do that. So we're just going to click the little thing over to the side that says, oh, that's a no solution. Absolute values can't equal negative values. So then we get to some little longer ones here. Here the absolute value is already by itself. You can't move the stuff out of there until you apply your rule for absolute value. So if this number here on the end is positive, you're going to write down 2 separate problems. It can either be equal to the +9 or to the -9. If this number over here is negative, then it's going to be a no solution. So in this case, I'm going to say either the -2u minus 9 could equal 9, because if the absolute value of 9 is still 9, or -2u minus 9 could equal the -9. Because the absolute value of -9 is still +9. And then I just solve those 2 things separately. So first one here, if I want to solve that, I'm going to add my 9 to move that over. Negative 2u equals 18. I divide by negative 2. U then equals negative 2 equals negative 9. So 18 divided by negative 2 is negative 9. Then I solve the other side. On the other side, again, I'm going to add my 9. So negative 2u would equal 0. 0 divided by negative 2 is still 0. And I'm going to get two solutions. U is either negative 9 or 0. And so I'm going to put them in with a comma in between. So notice the part that was in the absolute value didn't change. That stayed the exact same thing, just that number on the end. Could be positive 9 or could be negative 9. So on number 5, the absolute value of negative 4w plus 6 equals 10. Could be that negative 4w plus 6 equals the positive 10, or, since the absolute value of negative 10 is still 10, the negative 4w plus 6 could also equal the negative 10. So I'm going to write down my two problems. They call them case 1 and case 2 on Alex. And then I'm just going to solve them like I solve all my other equations. So to solve the first one, I'm going to subtract my 6. Negative 4w equals 4. And then divide by my negative 4. So w equals negative 1. W equals negative 1 is one of my solutions. On the other one, I'm basically doing the same steps, just that I have a negative 10 over there. So I'm going to again start by subtracting my 6. Negative 4w would equal negative 16. And then I'm going to divide by that negative 4, so w equals 4. So negative 1 and positive 4 are my two solutions to that equation. Now on number 6, we have the absolute value of 2u plus 6 equals negative 8. Since there's a negative after the equal sign, what do you think our answer is going to be? No solution. Absolute values can't equal negative numbers. So if there's a negative, there's not much work to do. You just click the thing that says no solution. I can't have a negative equal to my absolute value. Seven, 8, and 9 are solving ones where we have absolute values on both sides. So in theory, the absolute value of 9 could equal the absolute value of 9, but the absolute value of 9 also equals the absolute value of negative 9, right? So what they're going to do for their two cases is on the first one, they're going to leave everything the exact same. The 2u plus 6 equals the 5u plus 9. For the second case, they're going to leave one of them alone and do the opposite of the other one. So they're going to say 2u plus 6 could equal negative 5u minus 9. Notice I changed both of those signs. On Alex, they'll put a minus in front of parentheses and then distribute it out. Ends up doing the same thing. So, first case, they're both exactly the same as they originally were. The second case, I'm going to leave one of them alone and do the opposite of the other one. And then I'm going to solve them like I normally solve everything else. So on this one, I would minus my 5u to move it over, and minus my 6. 2 minus 5 would be negative 3u. 9 minus 6 is 3. Dividing, u is going to equal negative 1. On the second side, solving that, I got to move this over here, so I'm going to add my 5u and minus my 6. 2 plus 5 would give me 7u. Negative 9 plus a negative 6 is a negative 15. I'm going to get a fraction, that's okay. So my two answers, U could be -1 or -15/7. And there I have my two solutions. So on number 8, same kind of thing. I've got absolute values on both sides. I want to set up my two cases that I'm going to have. First one, just leaving everything exactly the same as it is. -4v minus 5 equals -7v plus 5. On the other one, I'm going to leave one of them alone. I usually leave the first one alone. So -4v minus 5. And I'm going to do the opposite of the other one. So I'm going to make that a positive 7v and a minus 5. So 7v minus 5. And then I have to solve both of my equations. So on the first one here, solving that, what should I do to solve that? Add my 7v and add the 5. 7 minus 4 would give me 3v. 5 plus 5 is 10. So when I divide, I just get 10/3, right? On the other side, in order to solve that, we would add the 5 and subtract the 7b. So -11v equals 0, and 0 divided by -11 is still 0, right? 0 can be an answer. V then could equal 10/3 or 0, and I'm going to put in those two solutions. So number 9, think about what your two cases should be, what you're going to write down on your paper to solve your problem. We have 2x minus 7 equals -2x plus 3. So on our first case, what should our equation say?
2x minus 7 equals 2x, -2x plus 3.
So we left everything exactly the same, just got rid of the absolute values. The second problem's going to be
2x minus 7 equals 2x minus 3.
exactly. So she left the left side alone, did the opposite of the right side. Most commonly on the assessments, when I see people miss the absolute value problems, it's because they forget to do two problems and they only do the one and just put in one answer. When I solve the first one here, I would add the 2x and add the 7. So 4x would equal 10. Then I'm going to divide by 4 and simplify, so my answer would be 5/2. On the second one, when I solve that, what would I do?
Minus 2 and plus 7.
Minus the 2x and plus my 7, and I would get 0x equals 4. If I have 0x equals 4, what's my answer to that part of it?
4.
Nope. Nope. Remember we had those ones where we had 3 different possible answers? A no solution, all real numbers are solutions, or you put the number answer in? 0 times what number gives me 4? Nothing, because I can't take 0 times anything and get a number other than 0, right? So if I have this is a no solution answer. I can't do that, and I'm only going to put in the one answer then. So in this case, I only have one answer, just the 5/2. So if there's a 0 in front of your x and it's not equal to 0, it's a no solution. The next one, solving inequalities. I do these differently than Alex because they make up all these weird rules and you have to look them up all the time anyway. Following the same idea of what we did here, I'm going to have two cases because I have an absolute value problem. The first one, I'm going to leave this exactly the same as it was, just without the absolute values. So 4x minus 2 is greater than 6. For my second case, when I make this a negative, I also have to flip my inequality sign. So for the second problem, 4x minus 2 is going to be less than my negative 6. And then I'm just going to solve those two things like I solve everything else. So I'm going to add my 2. 4x is greater than 8. Divide by 4. X is greater than 2. On the other one, same thing. I'm going to add my 2 first. 4x is less than negative 4. Divide by 4. X is less than negative 1. Question?
On my paper it doesn't say 4x.
Now, what did I have for my two answers? X was greater than 2. X was less than negative 1. So putting those on our graph, if we have the equal to bar underneath, we use the filled in dot. If we don't have the equal to bar underneath, we use the open circle. Put your end marks on first. So I'm going to put an open circle on the 2 and an open circle on the negative 1. I am greater than the 2, so I'm shading to the right side of the 2. I am less than the negative 1, so I'm shading on the left side of the negative 1. So when this is a greater than to start out with, you end up shading the two outsides because I'm greater than so many places from the middle of my crazy expression. And so if that's a greater than, you'll see on Alex, they're going to set up this whole thing and then they're going to say it's an or in between. It's an or in between because you end up shading the two outsides of your graph. So number 11, we're doing our absolute value problem with an inequality. We said that the first case, we're just going to leave it exactly the same. 4x plus 4 is less than or equal to 8. On our second problem, we leave the absolute value part, the 4x plus 4, and then when we do the negative, we have to flip our inequality sign. So we're going to make it greater than or equal to negative 8. We're then just going to solve those two inequalities separately. So on the first one, solving that for x, I'm going to minus my 4. 4x is less than or equal to 8 minus 4 is 4. Dividing by 4, x is going to be less than or equal to 1. On the other part, I'm going to minus my 4. 4x is greater than or equal to negative 12. Dividing by my 4, x is greater than or equal to negative 3. Looking at our end marks, we have the less than or equal to. Since we have the equal to, we use the filled in circle. So we have a filled in circle at 1. We have a filled in circle at negative 3. We are less than the 1, so we're on the left side of the 1, but we're greater than the negative 3, so we're on the right side of the negative 3. Which means our x value is between those two dots. Remember I said earlier, if this is a greater than, you end up shading the two outsides, like on the previous problem. If this is a less than, I'm less than so many places from the middle, I end up shading between my two dots. And that's why the Alex program has two different explanations, depending on if you have a greater than or a less than to start with. But I just do it where you have the original problem, and then you flip your inequality when you do the negative, and you should end up being able to see where you shade by the time you're done. Number 12. If I have the absolute value of negative 2x plus 7 is greater than or equal to 3, what should my two problems be? Negative 2x plus 7 is greater than or equal to 3. The same problem, just without the absolute values. And then my second problem should be
Negative 2x plus 7 is less than or equal to negative 3.
exactly. Negative 2x plus 7 is less than or equal to the negative 3, flipping my inequality and then changing the sign. And again, on Alex, they're not going to do it this way. They're going to set up this big long table and say if it's a greater than, you got to do it this way. If it's less than, you got to do it this way. Then you got to learn 2 different ways to do the problem. So solving this, we'll see if it comes out any better. I'm going to subtract my 7 first. So negative 2x is greater than or equal to negative 4. When I divide by negative 2, what do I have to do?
No solution?
Nope.
Oh.
When I'm solving an inequality and I divide by a negative, what do I have to do?
That was positive.
It does become positive. What do I do to my inequality sign? I have to switch it around. So x is going to end up being less than or equal to positive 2. When you solve your inequality, if you multiply or divide, which is usually the case, by a negative, you got to flip that sign. Now we're going to have to do that one and this one then too. So minusing my 7, negative 2x will be less than or equal to negative 10. And when I divide by my negative 2, my answer is going to be x is greater than or equal to 5 then, right? What kind of dots should I have on my numbers?
Filled in.
The filled in ones at 2 and at 5. And I'm shading less than the 2. So on the left side, greater than the 5, so on the right side. But you can see this was a greater than to start with, and we know that when we start with the greater than, we should end up shading the 2 outsides of our expression. And we did. So that's a good check. If that's a greater than, you shade on the outsides of the dots. If it's a less than, inside the middle of the dots. Because they're talking about a distance either being greater than so many spaces or less than so many spaces.
Say Linda,
Mm-hmm.
is that, what homework day are you on?
13. Only I changed those 3 problems a little bit.
Okay.
Angelique, she informed me that, oh yeah, and then I went, oh yeah, I did do that. So when I did them on the pie chart, they were a little different than what I originally had there. I didn't have any coefficients, but all the ones I did on the pie chart did have numbers in front of my variables, so I thought, oh, I'll just put a number in. Well, 2 out of the 3 worked out okay. 13, 14, 15 moves over into a different section of your pie chart, but still that algebraic symbol manipulation that we did a lot of in chapter 1. I want to solve these for y. I have a fraction there. Normally, if I have a fraction, I like to get rid of the fractions first by multiplying by whatever in the denominator. In this case, the variable is going to be in the denominator. So I'm going to go ahead and multiply both sides by y to get rid of that fraction. I'm going to have negative 8y equals negative 4 then, because my y's are going to cancel out. Now I have something that hopefully looks really easy to solve. I'm just going to divide by that negative 8 and simplify my fraction. Since I had a negative over a negative, it's going to become positive, and 4/8 reduces down to 1/2, so positive 1/2 is my answer. So number 14, if I want to solve that one, the first thing I should do is multiply by the x. If I do that, I'm going to get 9x equals negative 6. And then to solve it for x, divide by the 9 and simplify my fraction. So x is going to equal negative 2/3. And number 15, if I want to solve that one, multiply by the w. And I would get, whoops, 8 equals 6w, right? The w's are going to cancel out on the 8 side. So 8 equals 6w, and to solve it I would divide by the 6, and so my answer is going to be 4/3 equals my w. So probably would have came earlier in chapter 1, but since it's in a different slice of the pie, I just went around and once that one section was done, moved to a new one. And then they do it with just variables instead of having all the numbers in there. So if I want to solve this one for I still want to think about those same steps. If there's a fraction, I want to get rid of the fraction. So I'm going to start by multiplying both sides by the I. So I'm going to have IR equals E. Then I'm going to look at it and say, well, how do I get the I by itself then?
Subtract the R.
Not subtract it because it's not I plus R.
Divide.
Divide by the R, exactly. So I'm going to divide by the R, which means it's going to go underneath the E, and so I is going to equal E over R. So you kind of see how it works the same as those ones we just did before that had numbers in. Then they make them a little longer and a little more complicated, but same kind of thing. I want to get rid of the fraction as my first step, so the first thing I want to do is multiply by the t. If I multiply by the t, I'm going to have what? I equals PRT. It is case sensitive, by the way, so if it's in capitals, you'll have to type it in capitals, and if it's lowercase, use lowercase. I want to solve this one for the t, so now how do I get rid of the p and the r? I divide by both of them. So they're going to go underneath my I. To cancel those out. So I over PR is going to equal my t. And then in the same group, they have some proportions. How do you solve it when you have proportions? One fraction equal to another fraction. What's the first thing you usually do? We multiply by, what was that? The F and the A. What you're really ending up doing is you're cross multiplying, because if I multiply by the F and the A on both sides, one side the F cancels out and the other side the A cancels out. So usually when you have a proportion, you just say, I'm just going to cross multiply. So I'm going to have MA equals 6F, right? And then if I want to solve that for A, I would
Divide by it.
divide by the
M.
M, exactly. Divide by the M. So A equals 6F over M. So that gives you a little bit of variety of things you might see there on those ones.